Trigonometry, as we all know, trig short form. Triangle, as we know, is any area bounded by three straight lines. Any area bounded by three straight lines is a triangle. We have various types of triangle. Let's start with isosceles. Isosceles. The next, equilateral. Equilateral. Then we have right angle triangle. Then the D, well, scalene. From definition of A, which is isosceles. Isosceles triangle have two sides and two angles equal. The next type of triangle is the equilateral. Equilateral, from the word equal, means all the sides and all the angles are equal. And as we know, the sum of triangle is 180. So if you divide 180 by 3, it's going to give us 60 degrees. So that means each of these angles are 60 degrees because they are equilateral triangle. The next, which is C, right angle triangle, meaning one of the angle will be 90 degrees. It comes in all shapes and form. That is, one of the angle will definitely be what? 90 degrees. This various type of right angle triangle. One of the angle is definitely 90 degrees. We might be lucky to have a triangle that have 90 degrees and at the same time an isosceles. So that means if it's like that, this side will be 45 degrees, this side will be 45 degrees, and when you have 45 and 45, which is 90, 90 plus 90 will give you 180. Then the next type of triangle we have is scalene. If we are following the trend, we come to realize that if one angle have all the sides equal, the next angle, which is associated have two sides equal, that means scalene have none of the sides and none of the angle to be equal. So we're going to pick right angle triangle. Why right angle triangle is different and why it stands out. Right angle triangle problem can be solved by Pythagoras theorem. Pythagoras. Theorem. Pythagoras theory. Let's define it using it to solve right angles triangle. I said that angle triangle is triangle that one side must have 90 degrees, not more, not less. So now we're having triangle A, B, C, which is a right angled triangle. So we're going to define Pythagoras theorem using this triangle. As I said, it's only a right angle triangle. We can use Pythagoras theory to solve. So how does it go? Let's say line AB is letter X, line BC is letter Y, and line AC is letter what? Letter Z. So the definition of Pythagoras theorem says that the square of the longest side, that is the square of the longest side, which is line AC, is equals to the sum of the square of the two other sides. I repeat, Pythagoras theorem states that the square of the longest side equals to the sum of the square of the two other sides. Let's have an example. We have this line, and we say this line is 4 centimeters. Then we have this side, 3 centimeters, and we're looking for this side. Remember that the triangle is a right angle triangle. We can say, okay, this is X, Y, Z. And we're looking for what? Let's say we're looking for P. From the definition of Pythagoras theorem, the square of the longest side, which is the square of P, equals to the sum of the square of the two other sides. 4 square plus 3 square. So if we have to solve it, first the power of 4 to the power 2 is 4 times 4, which is 16. And the power of 3 to 2 is 3 times 3, which is 9. So P square equals 16 plus 9. You know that P square will be equal to what? 25. So let's look for the square root of both sides. We have to look for the square root of P square and the square root of 25. So we're going to have this, we cut out this. So it will remain P. Then 25 is same as 5 raised to power 2, which is same as this. So if this cut out this, we'll have 5 raised to power 1, and 5 raised to power 1 is same as 5. So that means P equals 5 centimeters using the Pythagoras theorem method. This is a standard method, and the only problem Pythagoras theorem can solve is only a right angle triangle. Right angle triangle can be solved with Pythagoras theorem. What about isosceles triangle and scalene triangle and equilateral triangle? If we can use Pythagoras theorem to solve right angle triangle, then we can use sine rule to solve isosceles, scalene, and equilateral triangle. What is sine rule? Sine rule states that sine A over sine of angle A equals sine B divided by sine of angle B, which is equals to C over sine of C. At the same time too, you can use cosine rule. Cosine rule to solve any triangle problem. Cosine rule says if you have the square of this side equals to the square of the two other side to this plus the square of the other side minus 2 times BC cos of capital A. This is sine rule and this is cosine rule. And these are the formula that we can use to solve the rest of the triangle. Sine 30, sine 45, and sine 60. They want to derive sine 45, cos 30, cos 45, and cos 60, and at the same time I want to derive tan 30, tan 45, and tan 60. But first, let's know what this word sine, cos, and tan, what they mean. So we're going to use triangle to define what sine is, what cos is, and what tan is. Sine, cosine, and tangent. Tangent. From using triangle, using this right angle triangle, once we have a triangle, we're using a right angle triangle, for example, and this is the angle that we know that is given. Let's call it angle X. So now I want to define angle X from triangle A, B, C. So now, let's say line BC is given small a, line AB is given small c, while line AC is given small b. That is, the angle opposite it, we claim the lines. So now, from this rectangle triangle, how can we get sine? In short, we call it sine for short. So now let's look for sine C. Why we call it sine C? Because sine C is what has what? The angle. So since C have claimed the angle, that means the side opposite this angle, which is small c, is called opposite. If you see, it is facing it. So automatically, these have claimed the name opposite. Opposite. So since these have claimed opposite, we're now left with this line A and line B. Then, we are looking at it, we know and we're sure and we're convinced that line AB is the longest line. Because the longest line will give it hypotenuse. Hypotenuse. So for what we have now, we'll say sine C is equal to opposite over hypotenuse, which is same as what? Line opposite is C, while our hypotenuse is what? Is B. So that's how we derive sine C. So now, if we want to derive another of the trig function, they call it trigonometry functions. If we want to derive another angle from here, we can only know the angle depending on where is given. Angles are always given. For example, now, if we are given this side, compared to what we have here, I'll still have A, B, C. Side B, side A, and side C. Then we are looking for cos A. What is cosine? Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So from this triangle now, we know that this is the angle that is opposite to this side. So this area automatically I've taken that name of what? Opposite. The angle always tells us where the opposite side is. Don't forget that. The angle shows us the opposite sides. It's the only angle is the only thing that changes. The only thing that remains constant that does not change is the longest side, which is what? The hypotenuse. And from the definition of cosine, cosine is adjacent side over the hypotenuse side. For what we have now, we know that this is the opposite side. This is longest side, which is what? The hypotenuse side. Which is left with what? With the last side, which is automatically what? Adjacent. So now, from our definition, cosine is what? Adjacent. What's adjacent from here? Which is C. Over hypotenuse. What's hypotenuse here? B. There's a proof I want us to look at. We're made to realize that sine over cosine equals tangent. We're going to prove this. That is, sine over cosine equals tangent. We have sine C to be C over B, cos A to be C over B. So now we have to prove that sine over cos equals tan. So how are we going to prove it? We're going to use another triangle to prove this so I can understand it. From this triangle, this is the angle that is taken. Let's say from X, Y, Z. So from triangle XYZ, this angle was picked. It can be an equilateral triangle, it can be a right angle triangle, it might even be a scalene or an isosceles triangle. But we're dealing with a right angle triangle. So with this right angle triangle, we want to prove that sine theta over cos theta equals tan theta. So we know that this side is the opposite side from the definition, because this is the angle that was picked, that was given. So this is the side it's facing, which is the opposite side. Then we said the longest side is always the hypotenuse. And the side that is left is what? Is the adjacent. Then we know that sine equals opposite over hypotenuse. So say sine theta equals opposite over hypotenuse. cos theta equals adjacent over hypotenuse. Then tan theta equals opposite over adjacent. Then to prove that sin theta over cos theta equals tan theta. Sin theta is same as sin theta divided by cos theta. What we have for sin theta? Sin theta is opposite over hypotenuse divided by cos theta, which is same as what? Adjacent over hypotenuse. Then mathematically, this same as opposite over hypotenuse times, this will be reverse, hypotenuse over adjacent. So this will cross out this. So automatically we are left with what? Opposite over adjacent. So what is opposite over adjacent? From our definition, opposite over adjacent is what? Tan theta. We're going to derive sine, cos, tangent of 30, 45, and 60. How do we go about it? We're going to use the triangle to discover it. We're going to use an isosceles triangle to get it. It goes this way. And the isosceles triangle at the same time will be a right angle triangle. So since I said it's an isosceles triangle, that means you know automatically these angles are what? 45. That is, two sides are what? The two sides are equal, the two angles are the same time equal, and this is what? 90. And as we all know, the sum of angles in a triangle is 180. So if you have 45 to 45, will give us 90 plus 90 will give us 180. But we want to derive something. What do we want to derive? We want to derive sine, cos, tangent of 30, 45, and 90. But now, since we have 45, we're going to derive sine 45, cos 45, and tan 45. So what are we going to do about it? Let's assume since these two sides are equal, this side is 1 and this side is 1. Just what I told you, the two sides are equal. That means the two angles are what? They are equal. That's an isosceles triangle. So to get this side, let's call it x. So we're going to use our Pythagoras theorem to get this side. As we define Pythagoras theorem, that is the square of the longest side, which is s squared, equals to the sum of the square of the two other sides, which is same as 1 square plus 1 square. And as we know, 1 times 1 is 1. Then the next 1 times 1 is 1. So that means we're having x squared equals 1 plus 1. And as we all know, if you don't know, 1 plus 1 is 2. That means we're going to look for we're looking for x. So what are we going to do is we're going to square. We're going to root both sides. When I say root both sides, that means we're giving them the power of half. That's what it means to square root them. So if we give a power of half, x will equal to what? Square root of 2. So that means automatically we we've now derived that this is same as square root of 2. Then, if you're using this to get sine, that means sine theta is what? Opposite over hypotenuse. So from what we have here, what is opposite using this angle? Opposite is 1. What's the hypotenuse? Hypotenuse is what? Root 2. So that means our sine 45 degree equals 1 over root 2. If we have to get our cos theta is same as adjacent over hypotenuse. What's our adjacent from here? Adjacent 2 is 1. 2 is what? 1 over root 2. So that means our cos 45 equals 1 over root 2. And remember that tangent equals sine over cos. So that means you can figure out tangent from 2 angles. We can start to look for tangent from our triangle. And from what you know, tangent at the same time is opposite over adjacent. So we have to figure it out from our opposite over adjacent. Opposite is what? 1. Opposite over adjacent. Our opposite is 1 and our adjacent is 1. So 1 over 1 equals 1. That means tangent is 1. Then if you want to figure it out using sine over cosine, we're trying to derive tangent 45 using sine 45 over cos 45. But before we do that, there's a notice. In maths, we don't allow a root in this form. What do we do instead? We multiply both sides with root 2 so that this can come up. So if you want to multiply this, you're going to have root 2 over 2, because 2 in 2 raised to the power half is the same as root 2. So when you do it that way, it's as good as having 2 into power half plus half, which is same as 2 raised to the power 1, and 2 raised to the power 1 is what? Is 2. So that's how we come about this 2. So therefore, sine 45 equals root 2 over 2, and the same applies for cos 45, which is the same as root 2 over 2. So back to looking for tan 45, which is the same as sine 45, which is the same as root 2 over 2, and cos 45, which is the same as root 2 over 2. Just from what we said, tan equals sine over cos. So our sine is what? Root 2 over 2 divided by root 2 over 2. In maths, when you have something like this, we have the inverse, that it will be 2 over 2 times inverse 2 over root 2. This root will cut this root. This root cut this root. 2 here 1, 2 here 1. So we are having 1 over 1, which is same as what? Which is same as 1. And as we know, tangent 45 equals 1. Sine, cos, and tan, 60 and 30. So we're going to start by using equilateral triangle. As we know, equilateral triangle, all the sides
are equal
and all the angles
are equal.
And the sum of angle in a triangle is 180. So if we have to divide 180 by 3, we're going to have 60 degrees. Meaning that all these angles are what? They are 60 degrees. So let's put these sides to be 2. Since we have equal angle and equal side. Then we want to get 30. So that means we have to divide this into 2. So automatically, we're going to have 30 here. Then this will give us what? 1. This is 1. So now, let's say x, y, z, and let's name this middle m. From here to here is 2. So from here to here is 1. So we are going to have picking triangle x, m, y. You know that this is 60. This is 90 degrees. And this is what? 30 degrees. We know that this side is 2. So we are looking for this angle y. So we're going to use Pythagoras theorem to get angle y. So the formula for Pythagoras theorem, that is the square of the longest side. The longest side is xy equals to the sum of the square of the two other sides. Zm squared plus xm squared. We are given xy, which is 2. So 2 squared, zm, which is 1 squared, plus xm, which is looking for, which is what? Y squared. What we have here is square of 2 is 4. 1 times 1 is 1. And we still have y squared. So making y the solution of the formula, y squared equals 4 minus 1. So y squared equals 3. So if we have to root both sides, we're going to have this. These two we call this. So we're having y square 1 equals the square root of what? Of 3. So y equals square root of 3. So automatically, this side now is what? Root 3. now gotten all the sides. That is, line xy is 2, line ym is 1, and line xm is √3. So now we want to get sine 30, and sine is opposite over hypotenuse. From this triangle, we're using this angle, which is sine 30. Opposite of it is 1. Then the hypotenuse is what? Is 2. That is, sine 30 is half. Then, getting cos 30, we same as adjacent over hypotenuse from this triangle. Using this 30, adjacent of this is √3. And the hypotenuse is 2. Then tan 30 equals sin 30 over cos 30. For what we have, tan 30 is same as opposite over adjacent. Opposite is 1. And what's adjacent? Adjacent is √3. That is tan 30. So using tan 30 equals sin 30 over cos 30. Sin 30 over cos 30. Sin, that is 1 over 2 divided by cos 30, which is √3 over 2. Over 2. So in mass, 1 over 2 inverse will be what? 2 over √3. 2 here 1, 2 here 1. So the 2 goes, so we are left with what? 1 times 1 is 1 over √3. So if we check it out, what's our √3? Our tan 30 equals 1 over 3. And the same thing goes, that is sin 30 over cos 30 still gives us what? 1 over √3. Which further prove that tan 30 equals sin 30 over cos 30. Then let's quickly derive our sin 60, which is opposite over hypotenuse. From here, we're using this 60. 60 is opposite, which is √3 over hypotenuse. What's the hypotenuse? 2. That is that. Then cos 60, which is adjacent over hypotenuse, which is from this. What's our adjacent? Our adjacent is 1. What's our hypotenuse? 2. That means our cos 60 is 1 over 2. Then our tan 60 equals opposite over adjacent. What's opposite? The opposite is √3. What's our adjacent? Adjacent is 1. So that is tan 60 equals √3.